Hello everyone, welcome to GEETHA'S classes. Today we are going to discuss about the course Discrete Mathematics MA 8351 under this Unit 4 Algebraic Structures. Okay, so in continuation of the previous video, we have seen Theorem 5 on subgraphs. So today we are going to discuss about problems on subgraphs. Okay, so I'll take one problem, problem number 1. If H1 and H2 are subgroups of a group G, star, prove that H1 intersection H2 is a subgroup of G, star. Okay, so given H1 and H2 are subgroups of group G, and we are going to prove H1 intersection H2 is a subgroup of G. Okay, so it's an important university question. Prove that this question can be asked like this also. Prove that the intersection of any two subgroups of G, star is again a subgroup of G, star. Okay, so the same first part can be asked like this also. Okay, so instead of this notation, they have given the intersection of two subgroups. This is again a subgroup. So both the questions are same. If they are asked in these two forms, you have to write the same answer. Okay, so let us see the solution for this problem. Let us take H1 and H2 are subgroups of G, star. This is given in the question itself. Okay, so that is given in the question. Okay, now we are going to take A, B belongs to H1 intersection H2. Let us take two elements belongs to H1 intersection H2. So H1 and H2 intersection means and, right? So we can write A, B belongs to H1 and A, B belongs to H2. Okay, so you know H1 and H2 are subgroups. Okay, subgroup means it satisfies theorem 5, right? What is theorem 5? If H is a subgroup means A, B belongs to H implies A star B inverse belongs to H. Okay, that is theorem 5. So that we have done in the last video, right? So here A, B belongs to H1 implies A star B inverse belongs to H1. So let us finish H1 first. Okay, A, B belongs to H1. So let us take that one. So A, B belongs to H1 means by subgroup definition we are writing A star B inverse belongs to H1. Okay, similarly for H2. A, B belongs to H2, you take this H2, okay. A, B belongs to H2 implies A star B inverse belongs to H2, okay. So A star B inverse belongs to H1 and A star B inverse belongs to H2. So both it belongs to H1 and H2. So and means you have to use intersection, okay. So therefore A star B inverse belongs to H1 intersection H2. Okay, so we have taken A, B belongs to H1 intersection H2. This implies we have proved A star B inverse belongs to H1 intersection H2. So this is the subgroup definition. Therefore, H1 intersection H2 is a subgroup of the group G. Okay, so hope you understand this problem. We will continue the next theorem in the next video. Thank you.